Okay, class, welcome to our next math lesson. We are today on Module 1, Lesson 2. Only this time it is Part B. Yesterday was Part A, this is Part B, and yesterday was multiplication of exponents. Part B today is going to be about the division of exponents. Dividing exponents. So let's look a little bit about what the rule we did yesterday was. Yesterday, just to remind you, the rule we came up with looked like this. X to the m times x to the n equals x to the m plus n. As an example, we could look at this. We have 3 to the 5th times 3 to the 7th equals 3 to the 5 plus 7, which means 3 to the 5th times 3 to the 7th equals 3 to the 12th. When we multiply exponents, if the bases are the same, remember, bases have to be the same. Multiplying exponents with the same base, we add the exponents. If the bases are the same and we are multiplying, we add the exponents. But today's something new because we're not multiplying exponents. What about this? What about this? Instead of multiplying, let's talk about dividing. What happens if it's not 3 to the 5th times 3 to the 7th? What if it's 3 to the 7th divided by 3 to the 5th? Well, let me show you what we're going to do. Just like we did with multiplication, we are going to stretch it out to simplify it. I want to show you what it looks like without the exponents. So let's stretch this out. 3 to the 7th turns into 3 times 3 times 3 times 3 times 3 times 3 times 3. That's 3 to the 7th. 3 to the 5th, when we stretch it out and lose the exponent, we get 3 times 3 times 3 times 3 times 3. So that's what it looks like stretched out without exponents. That should also show you how much better exponents are, because instead of writing all this, we just write something simple like that. So what's the next step with this? Well, remember, this is a division problem. A fraction is a division problem. Something that I like to tell people, a fraction is a bar with a number here and a number here. A fraction is a bar with a number on top and a number on bottom. A fraction is a bar with a numerator and a denominator. So a fraction is just a division problem. So we have a fraction here which with lots of 3's in the numerator, lots of 3's in the denominator. Let's simplify this by dividing. When we divide, we are going to do on this one, divide to make ones. Watch what I do. I just look at the pieces. 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3, 1. 3 divided by 3, 1. 3 divided by 3, 1. So all of these turn into ones. Now we have 1 times 1 times 1 times 1 times 1 times 3 times 3. So there's actually, everything turns into 1s multiplying by 1, which doesn't change anything. That's the identity property. Except we have these 3's in the numerator, and we have 3 2 times. So this, after we cancel and make all the 1s, we are left over with 1s times 3 2 times. And 3 2 times can be written like that, exponent. 3 2 times is just 3 squared, and there's only 1s in the denominator, so we don't have to have the denominator anymore because there's only a 1 there. We don't need to write the denominator if it's only a 1. So after doing this, we see that 3 to the 7th divided by 3 to the 5th equals 3 to the 2nd, also called 3 squared. So, question, do you see the shortcut? Do you see it? Do you see the connection between both sides of the equal sign? What if I do this? 3 to the 7th divided by 3 to the 5th equals 3 squared. What happens if I point out these to you? By looking at the exponents in this equation, do you see a connection? Do you see a shortcut? Do you see it? How about now? Do you see it? Hopefully you see that the fact family, 7, 5, and 2, you can see that 3 to the 7th divided by 3 to the 5th, the shortcut is you just do 3 to the 7th minus 5. And that's how we get 3 squared. So when we divide exponents, we subtract. Remember yesterday, let me go back up to the top of our notes. Multiplying exponents, we add the exponents. Dividing, we subtract. So today's rule is going to be when we have two bases dividing with different exponents, x to the m divided by x to the n, we just do x to the m minus n. Now remember, it is the numerator exponent for subtracting the denominator exponent. The numerator exponent goes first. Do not switch them. That'll mess you up. M on top, so m goes first. Subtraction, the order matters. Also remember that when we divide, just like when we multiplied, the bases must be the same. Just like yesterday, the bases must be the same. So that's another rule you have. So we have two rules. The first rule was that multiplying bases, we add the exponents. Dividing bases, we subtract the exponents. Let's do a little bit of practice with this. Hopefully you wrote your notes down in your notebook or on a separate piece of paper. Our practice time is going to start on page 13. Now you look at page 13 and you recognize the first two problems, exercise 19 and 20. We did them yesterday, so we're not going to do them again today. We're going to go down to the next section for part B of lesson 2. And you can see they give you the rule again as a reminder. So you have it in your notes and you have it on the top of your work. Let's look at exercise 21. Exercise 21, 7 to the 9th divided by 7 to the 6th. Now remember, you can stretch this out if you want. 7, and you put 9 sevens in the numerator, and you can put 6 sevens in the denominator because you're stretching out the exponent. And then you could turn them into 1. 7 divided by 7 is 1. 7 over 7, 1. Divide to make 1, divide to make 1, divide to make 1, divide to make 1. And what's left over? Well, we have a bunch of 1s in the numerator, a bunch of 1s in the denominator, and we have the 3 7s. So this is going to be 7 to the third, because there's 3 7s in the numerator left. Or you can use our shortcut, 7 to the 9th divided by 7 to the 6th equals 7 to the 9 minus 6 equals 7 to the third. Do it either way you like. Now, for exercise 22, works the same way. Remember, just follow the rule. We just take the bases are the same. Look, the bases match, so we can just subtract the exponents. So we get negative 5 to the 9th power. That's our answer. I'll actually take either answer. They are both good. Try exercise 23 and 24 on your own. Pause the video right now and see if you can solve them, and we'll check the answers in a minute. Okay, if you pause the video, you're coming back to check our answers. For exercise 23, the base is 8/5, so we do not have to change the base. The base just stays the same. We just subtract the exponents. So simplified, number 23 is 8/5 to the 7th. Exercise 24 was a fun one. You should have done 13 to the 5 minus 4, and you get 13 to the first power. Now, if you left it like this, that's okay, but you should also remember that this just means 13 one time. So you could just write 13 if you want. We talked a little bit about that yesterday. 13 and 13 to the first are the same. You don't believe me? Stretch this one out. Put 5 13s in the numerator and put 4 13s in the denominator to stretch it out. Cancel to make your 1s. 13 divided by 13, 13 divided by 13, 13 divided by 13, 13 divided by 13. The only thing that's left is a 13. So you see 13 and 13 to the first are the same. Going to next page, page 14. Go there with me, please. And this time we have the same kind of dividing of exponents, only this time it's variables. And remember, don't be scared by the variables. Don't be confused by the variables. You just do the same thing. The base is a over b, so keep the base the same. And it's dividing the same base, so we subtract the exponents. So we get the base a over b to the 7th. And it's the same thing with number 26. Pause the video and try number 26, and I'll come back and we'll talk about it when you're done. For number 26, we just do x is the base, and so it's division of the same base, so we subtract the exponents. We get x to the first, which remember is just x. Just like we did on page 13 with number 24. Now, the next 4 exercises are a little bit tricky because they are showing you how to combine bases that don't look the same at first. Like in exercise 27, you'll see like, wait, 2 to the, here, let me cover it up again like I did yesterday. 2 to the 7th divided by 4 squared. The first thing you're going to say is, Mr. Baylor, those are different bases. You said the bases have to be the same to use our rule. I did. The bases have to be the same. But 4 and 2, 4 can be changed to match the base because 4 squared is 16. And 2 to the 4th is also 16. So this is 2 different ways to write the same number. If I write it this way, I cannot simplify. But if I write 16 like this, I can simplify. I just do 2 to the 7th minus 4. So the answer is 2 to the 3rd, or 2 cubed. Changing the base while it's still 16. I only changed what it looked like. I did not change the value. This is still 16. This time it's wearing that mask, this time it's wearing that mask, but 16 is behind both masks. Number 28 follows the same kind of thing. You see a 27, you're like, well, Mr. Baylor, those are two different bases. I cannot simplify that. Well, yes, you can, because 27 is really 3 to the third. Because 3 times 3 times 3, 3 times 3 is 9, 9 times 3 is 27. Both of these are 27, they're just wearing different masks. But when we put this mask on, 3 to the third, the bases match. I can subtract the exponents, and I simplify. For exercise 29, you're like, oh, wait, Mr. Baylor, this is not as easy. There's a bunch of numbers in the numerator. There's a bunch of numbers in the denominator, and you might be freaking out. Well, don't do that. Instead, just look at the common ones. So you can just do it one piece at a time. Just look at the 3's first. And you say, oh, I can just do that. I can look at the 3's. Get a piece of paper, cover up the other side. 3 to the 5th divided by 3 to the 2nd is just 3 to the 5 minus 2. But don't forget the other bases. Times, this time we have to do the 2's, 8 minus 3. And put it all together, we get 3 to the 3rd times 2 to the 5th. And that is simplified. We don't have to put the 3's and the 2's together. They are different bases. But we can put the 3's and the 3's together and the 2's and the 2's together. Same with exercise 30, which I would like you to try right now. Pause the video, try number 30. Remember, cover up the sides if it helps you. Go for it. And we're back where you can check your work you just did on number 30. You could cover it up, but let's do the negative 2's. We do 7 minus 5 times the 95, and we do 5 minus 4. We do the negative 2's together, we put the 95's together, we keep them separate from each other though. So this turns into negative 2 squared times 95 to the first, which negative 2 squared times 95, because remember 95 and 95 to the first, same thing, but this looks simpler, uses less ink. People like it better like that. So those are exercises 27, 28, 29, and 30. Let's go to page 15. And 15, exercise 31 is something you're really going to like. It's 3 different sets, part A, part B, part C, and it's asking us to simplify this. Now here's where it might be confusing to you, because you might not know, okay, you might know that parentheses means multiply, but we're supposed to multiply 5 over x to the third times 3x to the eighth. But which parts get multiplied? Well, what I like to do is I like to remember that this 3x to the eighth is always just divided by 1. It is a fraction, but it is a fraction with a 1 in the denominator. This is just divided by 1. When I write it like a fraction, though, it lets me see how to do it, because now I have 3x to the eighth over 1. And you should remember, when we multiply fractions, all you do is you just go straight across. So the numerators get multiplied together. 5 times 3 is 15. The x to the eighth has nobody to play with, so it stays. X to the third times 1 is x to the third. Done. Then you do what the rule we practiced today is. The 15 can stay by itself because there's nothing in the denominator to change it. And we do x to the eighth minus the 3, following today's rule. So we get 15x to the fifth. And that is our answer. Simplified. Try B and C. And come back and pause the video, and we'll come back in a minute and work on B and C. Okay, here we go. Remember, this in the parentheses does not look like a fraction, so make it a fraction. Just put it on top of 1. And that dividing by 1 does not change the number, but it makes it look like a fraction, so it's easier to work with. It's the same thing, we just made it look like a fraction, so now it's obvious how to multiply this. Numerator times numerator, 5 times negative 4 is 20. The x to the 6th remains the same. X cubed times 1 is x cubed. And simplify the variable part using today's rule, x to the 6th minus 3. On your own, you should have got negative 20 x to the x cubed, x to the 3rd. And that is the answer. When you did part C, remember also, this does not look like a fraction, so just make it look like a fraction. Divide by 1. Dividing by 1 stays the same thing, but now it's a fraction that we can use. Multiply straight across, 5 numerator times numerator, then denominator times denominator. 5 times 11 x to the 4th is 55 x to the 4th. X cubed times 1 is x cubed. We get 55 x to the 4th minus 3. Simplifies to 55 x to the 1st, but you know x to the 1st is the same as just x. There we go. Hopefully you got all those. If you did not, there's more practice on Khan Academy. You can call me and ask for my help too. Moving on to exercise 32. Anne used an online calculator to multiply 2 billion times, looks like 2 trillion. The answer showed up on the calculator as 4e plus 21, as shown below. So that's what it looks like when you type it in. Is the answer on the calculator correct? How do you know? Well, you've probably seen this before. You know that when you multiply, let's say, 10 times 10, you do the 1 times 1, and you put on 2 zeros. If you multiply 10 times 20, you do the 1 times the 2, and there's 2 zeros. You multiply 30 times 20, you do the 3 times the 2 to make the 6, and you put on 2 zeros. So because you know those simple rules, you can figure out this one. So looking at the problem that Anne typed in, she had 2 billion times 2 trillion. The 2 times the 2 is going to be 4, and then we have to add on all of these zeros. Well, how many zeros am I going to have to add on to the end of this 4? You can just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I'm going to add 21 zeros. So this is 4 plus 21 zeros. And if you look at the calculator, 4 plus 21. So this on the calculator must mean 4 plus 21 zeros. And that's what it means. So I'd like you to explain this yourself. First of all, is her answer correct? The answer is yes. But I would like you to give your own explanation after the yes, because you're supposed to say, how do you know also? I'm telling you yes, you tell me how we know. Summarize what we just did together. And after pause the video, write your summary, and then unpause and come back, and we'll work on, we'll talk about the exit ticket you're going to do today. And this is the exit ticket. Now, the exit ticket for lesson 2 is going to combine yesterday's work and today's work. There will be there's 2 questions about multiplying bases with exponents, and there's 2 questions about dividing bases with exponents. I'm going to want you to do this yourself, and you can check your work because on the daily schedule I have the answers linked. So I'll give you the answers now, or you can check your, you know what? Yeah, just check your work on the answers linked. If you are curious, you can check your work on the answers linked on the daily schedule. I will give you one hint though. This 25, do not tell me it can't be done because 25 is 5 squared. Because 25 is 5 times 5, which I change into 5 squared. So you can do that one. So do that and then check your answers following the link from the daily schedule. If you are stuck, remember these lessons are nice. They give you something called a homework helper that tells you looks like on this page they give you 8 examples about how to do both multiplying exponents and dividing exponents. So it'll help you do both with 8 examples. Use the homework helper. And let's talk about the problem set for a minute, because I will do the problem set with you because problem set is a little bit painful. At least number 4 and 5 are painful. Number 1 and 2 would have been painful if I were making you do them, but you do not have to do number 1 and 2. I'm crossing it out. You don't have to do it. I do want you to do number 3, though, because number 3 is some good review. There's the multiplying of the bases for this one, this one, this one, and this one. And then there's 2 practicing dividing bases. Again, just like the exit ticket, I'm not going to do these now. I would like you to do number 3 as on your own practice, and you can check your answers on the answer page linked on the daily schedule. I will, however, do number 4 and 5 with you because these require me to, some of you might be able to figure it out, but I really want everybody to understand how to do these. So I'm going to think out loud while I solve these. Number 4, let the dimensions of a rectangle be that ridiculous thing. So remember, a rectangle is length and width. So this whole complicated thing right here is the length, and this number is the width. And it wants us to find the area of the rectangle. And in case you forgot, area of a rectangle is length times width. So we have to multiply this times this. And that looks like it's going to hurt. But we can make it a little bit easier. Let me show you how to make it easier. First, do you notice how this number is exactly the same as that number, and that is exactly the same? Instead of writing those long numbers, I'm going to change them to variables. So I'm going to take 871209, and I'm going to say that equals x. And the 497,62105, that's going to equal y. Now, every time I see this, I write x instead. Every time I see this, I write y instead. So now, instead of length times width, which with some super long numbers, I'm going to do this. I get 4 times, not that, that's x now, 4x to the 5th plus 3, and that is just y. Remember, if it helps, x and y. So that's just 3 times y, so just 3y. That's my new length, much simpler. My new width is 7, and there's x again, because I labeled it there. Minus, that value is y to the 4th. That is a much easier length and width to understand. Much easier to write. But now I still need to find the area. So I do length times width equals area. Now we did practice this yesterday. I hope you remember that everything needs to be passed to everything else. So what we're going to do is, remember, we have 4 pieces. This number gets passed to everything inside the other parentheses. So it gets passed to that one, and it gets passed to that one. And the 3y also gets passed to both. So you have to do 4 multiplications. You follow the 4 arrows. The first one, 4x to the 5th, follow this arrow, times 7x to the 3rd. So 4 times 7 is 28. And then we have x to the 5th times x to the 3rd. Plus 4 times the y. Now this is not just y, look here, it's a negative y. So what I like to do, instead of doing minus 4y, I just say plus a negative 4y. Keeps it simple. I just know this one is negative now. So 4 times the negative makes negative 4. And x to the 5th, y to the 4th. Plus, now I'm ready for the 3y. The 3y goes to the 7x cubed. 3 to follow this arrow now. 3 times 7 is 21. And we have a y, and we have x cubed. And then we have the last dark blue arrow. The 3y goes to the negative y to the 4th. 3 times negative is negative 3. And we have y and y to the 4th. Now this can be simplified even more because these pieces go together. The x's are multiplied together, so you know you can just add those. X to the 5th, x to the 3rd is x to the 8th. X and y, different bases, so nothing changes for the second piece. Y and x, different bases. The only thing I'm going to change is I'm going to do alphabetical order and put the x first, but everything else stays the same. And then for the last one, we have y to the 4th. Remember, y by itself is really y to the 1st. So this turns into y to the 5th. So this is the area. Although we are not done yet, we have something painful to do. You need to put the numbers here back in here. So every time you see x, you have to write this. Every time you see y, you have to write this. So we made it easier with the variables. Now we have to replace the variables for all of the information. So we're going to get 28. And then there's an x, so we do 871,209 to the 8th. Plus negative 4. There's an x, so we do 871,209 to the 5th. There's a y, so we do 497,62,105 to the 4th. Plus, I need a second line for this, 21. X to the 3rd. It's not x anymore. It's 871,209 to the 3rd. And then there's a y. So I get 497,62,105 all by itself. No exponent. Plus the negative 3. There's a y. 497,62,105. And this y goes to the 5th. And that is the answer right here. So the area equals this monster, but don't forget it's measured in feet. So the area is, you can read that, I'm not going to try. It is that number square feet. See how much fun that problem was. And now you're super happy I did it for you on the screen. Let's go to number 5. So take a pause if you need to rethink that. Go back and re-watch that. If you don't know what I just did with number 4, it is okay if you go back and watch it again. That's why we're on video, so you can rewind. Looking at number 5. A rectangular area of land is being sold off in smaller pieces. The total area of the land is 2 to the 15th square miles. The pieces being sold are 8 to the 3rd square miles in size. How many smaller pieces of land can be sold at the stated size? Compute the actual number of pieces. So, a lot of words. Let's think it up. They have a big piece of land and they're selling it in pieces. So they're taking one big piece of land and breaking it into pieces. That means they are dividing a big piece of land. So what they are doing for number 5, they are doing the whole land divided into pieces of land. So they're taking the whole land and dividing it into pieces of land. That's all, that whole paragraph, that's all they're doing. They're taking land and they're making it into pieces, and they're selling one piece at a time. So let's take this word sentence of what's happening and put our numbers in it. The whole land. So in the problem it says the total area is to the 15th. So instead of whole land, we have 2 to the 15th. Divided, use the symbol means divide. And the pieces, how big are the pieces? 8 to the 3rd. So that is our problem. We have 2 to the 15th divided by 8 to the 3rd. To keep it simple, I'm going to write like a fraction, 2 to the 15th divided by 8 to the 3rd. And you're right now, some of you might be saying, Mr. Bader, the bases are different. Can we stop? No, you can't stop because the bases just look different, but you can make them the same. But don't worry, I'm going to tell you how. Because what happens is you can keep it at 2 to the 15th. 8 to the 3rd is 2 to the 9th. And then you can do the work. So, then you can do the work. Now you just know it is 2 to the 15th minus 9, so it's 2 to the 6th. But they want to know how many pieces that is exactly, not the exponent. So you have to stretch it out again. 2 times 2 times 2 times 2 times 2 times 2. And tell me how many pieces that makes. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So they will make 64 pieces out of that land. The trick for number 5 was summarizing the question in your own words, which is just they're taking the whole land, dividing into pieces, finding the values, and then changing 8 to the 3rd to 2 to the 9th. But if you did all that, you got 64 pieces. So that is all of lesson 2, part B. I would like you to work on the exit ticket that we did not do together, work on the problem set that we did not do together, check your work with the answer keys linked on the daily schedule, and go to Khan Academy for some more practice. If you need any help, if you need to watch this again, you can rewind, watch it again. If that still doesn't work, you can ask a friend. If that still doesn't work, send me an email, ask me a question. I am here to help in whatever way I can. Thank you very much. Have a good day.